All right, so checking your answers for number 4. So we should get the formula 4,200 times 0.9 to the t. It's decay because it decreases. And 1 minus 0.10 is 0.9 for the base, for the decay factor. Plugging in 3, you get that it's $3,061.80. And then looking at the graph over here, again, we can't extrapolate, so 0 to 10 is usually the x value. And then this one, the y-intercept is 4,200. So you can kind of interpret that that's 5,000. So they go by thousands here. So if we were to graph the 2,000 mark, right here, horizontal line at 2,000, and then we would just look at our y equals. So in y1, we type in the 4,200 times 0.9 to the x. And in y2, we type in our 2,000 with this window, 0 to 10, 0 to 5,000. Second trace, number 5, enter, enter, enter. Gives us that time is 4.92 years. Which again, we would round it to 5, probably in answer choices. I won't ask you for exact until we get to solving, but you can get solving right now, and then we can find the algebraic part later. We can estimate it once we know how to get the exact. All right, the other 3, they're very short. They're very similar to growth and decay. So there's a doubling formula, there's a tripling formula, and then there's a half-life formula. So notice a lot of these are the same values. The A is your initial amount. We don't have an R value because for doubling, the base is 2. Tripling, the base is 3. And half-life, the base is half. The part that is different is the P value. P is the period that it takes for the number to triple or to double or to cut in half. So P for all of these times for the exponent is how long does it take to double? How long does it take to triple? And how long does it take to be cut in half? All right, so if we look at example 5, it says a population of bacteria doubles every 3 days. So I know I'm using the first one here. So N equals, if the initial population is 1,500, so the initial is your A value, so A is 1,500. I know it's a doubling, so I'm going to multiply by 2 to the T divided by P. So right here, how many bacteria are in the colony after 3 weeks? So the 3 weeks is what it's asking us. This is the time. But we need these units to be the same. So if this is in weeks and that's in days, we need to convert this to days because it's easier than converting that to weeks. So 3 weeks is 21 days. So we're going to do 21 is the T divided by the period is how long it takes to double, and it takes 3 days to double. So this would be your period. So in the calculator, we're doing, so clear all this, 1,500 times 2 to the 21 divided by 3 is just 7. So then there are 192,000 bacteria. All right, so here it's actually 100% growth is what the R value would be, because 1 plus 1 is 2. So this, if you wanted to get the R, you could, but when it doubles, that's 100% that it's growing. All right, for example 6, a culture of bacteria triples every 8 hours. If there are 100 bacteria now, how many will there be in 18 hours? All right, so let's look what we need. So first of all, we're doing the tripling one, so we're using the second equation. N equals the initial amount is 100 bacteria. So 100 times triples has a base of 3. And the exponent, we do the time that we want divided by the period. So the time that we want is 18 hours. So 18 is the numerator, but then we divide that by the period, which in this case is the 8 hours here. So 8 goes in the denominator. I mean, you can reduce this and simplify it, but since we're going to type it in the calculator anyway, we can just leave that as the exponent. 100 times 3 to the 18 over 8. And we get this number for n, but we're talking about bacteria, so we can just round it to the nearest whole number. So 1,184 bacteria. Now, half-life, you see half-life and radioactive decay. So if you put something out on the ground, how long does it take for the substance to reach half the amount that it started with? So that's when we use half-life, is for decay. So here it says the half-life of carbon-14 is 5,730 years. A plant contains 100 grams of carbon-14. How much carbon is left after 200 years? So because it says half, I know I'm going to use this one. N equals, how much did I start with? So I started with 100 grams. So 100 goes here. And we're talking about half-life. So half. And the exponent, the time that I want, is 2,000 years. So we do 2,000 divided by the period, which is 5,730. Now, if you've heard of carbon dating, the reason they use carbon to figure out, how old something is, like a fossil or something that they find, is because it takes so long for it to decay. It takes, for half of the stuff to decay, it takes 5,000 years. So more than 5,000 years. So there's still stuff left. Depending on how much stuff is left, will tell you approximately how old it is. So then we just put this into the calculator, times 1/2 to the, and then we just divide these. 2,000 divided by 5,730. So N equals, and we can have decimals here because we're talking about grams. So we can say 78.5 grams of carbon. So again, it hasn't even lost that much. It's been sitting for 2,000 years, but it hasn't lost much of the carbon that it started with. All right, so those are just special cases. Most of the time it's growth or decay. So tomorrow we'll do the interest rate ones, and then we'll be done with the modeling. So now you can work on your homework or get the new homework.